So in this example, we have a ball being dropped from a height of 20 meters. And we want to know its speed when it hits the ground. Well, its speed is related to its kinetic energy, so we need to know what the kinetic energy of this ball is when it hits the ground. We have no idea what that would be. What we do know is we know that the potential energy of this ball is all the energy that it has to begin with, and when the ball hits the ground, it will have converted all of that potential energy into kinetic energy. So if we start off by finding the potential energy, we can go from there. So to find potential energy, take a look at what we have. We have the mass of the ball, 10.0 kgs. We have the height of it, 20.0 meters. And for potential energy, we're always dealing with acceleration due to gravity, so g, 9.8 meters per second squared. We know that potential energy, Eg equals mgh. We can fill in what we know. M is 10 kgs. G is 9.8 meters per second squared. H is 20.0 meters. And we get that Eg is 1,960 joules. I'm not concerned with sig figs at this point because this is not a final answer. This is just one step along the way. And what we know is that since energy is conserved, we don't lose, we don't gain. The kinetic energy at the bottom of this cliff is also 1,960 joules. Knowing this, we can go and we can find the speed of the ball as it hits the ground, because we know that Ek equals 1/2 mv squared. Ek is 1960. Mass of this ball is still 10 kgs, and v is what we don't know. Doing the math here, we'll do 1/2 times 10.0, that's 5. So we have 5v squared. Divide both sides by 5 and we get 392 equals v squared. Take the square root of both sides and we get that v is 20. And we need 2 sig figs on that, so we'll put a line over the 0, 20 meters per second.